Welcome back, everybody. That's kind of fun. When I do this, I have multiple monitors. You can see I was listening to Guns N' Roses over here on my other one. Guns N' Roses, Don't Cry. If you're not familiar with them, that's a pretty good song. But this one right here, Patience, listen to that one just recently. Patience is great. Anyhow, my generation, I talk to people, students these days, I'm like, have you ever heard of U2? A lot of students haven't heard of U2 or Bruce Springsteen, or I don't know about Guns N' Roses. Maybe they're more popular. Time goes by in a flash. There's this great quote. We're going to get philosophical here for a moment. Thus shall you think of this fleeting world. And it's the Diamond Sutra from Buddhism. Lots of great stuff in all the world's different belief systems. But thus shall you think of this fleeting world. Right here, a star dawn, a bubble in a stream, a flash of lightning in a summer cloud, a flickering lamp, a phantom, and a dream. So it seems like I blinked my eyes, and it was the 80s, and this band was like, wow, they're amazing. And it's actually one of the top albums of the 80s, top 10. I can't actually think of an album that is better than it. Of the 80s, Guns N' Roses, Appetite for Destruction, very powerful album. Amazing. So anyhow, time goes quick. Now you're the students and I'm the teacher, and we're going to learn about statistics. But first I'm going to shut the door because we got family in the house. Okay, we're recording again, and I think that was a minute, 30 seconds well spent. You learned a really cool phrase, the Diamond Sutra, about this fleeting world and impermanence, and carpe diem. Carpe diem is also a really cool phrase. Carpe diem, seize the day. There's an entire category of poems around carpe diem, so you could say carpe diem poems. But of course, this would probably be better answered at ChatGPT. And so I'm going to go here to chat and do a new chat, and I'm just going to like get rid of that one there. I don't need it anymore. And I'm going to drop that chat in there. And here are a few notable carpe diem poems. They're kind of fun to read. Oh wow, they actually list out some of the poems here. A Song of Living, I don't know that one. And anyhow, it's about making the most of your time while you got it. All right, let's get going. We're going to learn about sampling and sampling distributions. We're in Module 7, Chapter 7, and we're going to learn all this stuff. You can pause the video. X bar is a mean, and then P bar is going to be for proportions, and we're going to learn that. And so here in the introduction, we're going to go over a few things which, we've already learned some of the stuff. So an element is the entity on which data are collected. So if you remember, like way back, Chapter 2 or Chapter 1, Module 1, Module 2, we looked at like different countries, and then we looked at like, I think GDP for the country and maybe some other data. And so each country was an element. And if we go to that Gapminder website, gapminder.org, and then we go to the data at gapminder.org. So I'm just going to go down to the data. I'm going to go down to the data. So that's like, I don't know, under resources, animating data. And I guess it's up here at the top. I'm all the way at the top. Upgrade your, here we go, resources is what I'm looking for. And teaching and Gapminder and tools and factfulness and frameworks and downloads and data. Download the data. We'll go to data. And so we get to data, and then here in data, we could take a look. And this, I don't know, we did this earlier too, but I just wanted to have some data to sort of show this. And so here's GDP per capita. So we'll take a look at that. And I have an email, which is what that sound was. And so GDP per capita, here we have the different years, and we have GDP. And just to make this a little bit more relevant, I guess we could scroll down here and go to the more current years, like right there. And these are each an element. Right? So each of these countries is an element, and this is the data that's been collected about that element. So if we look at that, an element is the entity on which data are collected, and data could be singular or plural, and here it's being plural, so you're saying many pieces of data are collected. And a population is a collection of all the elements of interest. So the population would be all of the countries, and a sample is a subset of the population. The sample population is the population from which the sample is drawn, right? So I'm going to just put this under here because that's how my brain thinks of it, because here we have population, right? And there's population. I'm going to highlight that. And the sampled population is the population from which I'm going to say a sample is drawn. So, you know, right, like that's a population that's been sampled. It's a sampled population. And what is a sample? A sample is a subset of a population. And a frame is a list of all the elements that the sample will be selected from. And so I'll put this here, right? Because that is kind of like, you know, a new phrase, and we'll highlight this one like that. So that's just some terminology. So you have a population, right? When we're talking about sampling, how do we sample and get data about the world? How do we do different samples and get different pieces of data about the world to understand the world? Well, we have entire populations that are out there. And so one population might be all of the people, every single citizen in the United States of America. And so if we wanted to understand the people of the United States of America, one way we could do that is to get data from each and every person in the population. And each and every person in the population would be an element. Every person would be an element. But that'd be a lot of people to gather data from. And by the way, if you gather data from an entire population, whether it's like all the people in America, or all the people within Google, all the employees within Google, or that'd be the population of the employees at Google, or all the students who go to a particular school, that'd be the population, right? All the students who go to the school. And if you do, you know, some sort of sampling of the entire population, that's called a census, right? So a census is gathering data on all elements in a population. So we'll kind of just highlight that one too. So we'll do that. And I feel like I'm having to catch my breath here. So you have a population, right? All the people in America, but that's a lot of effort, a lot of time, a lot of cost. So instead of like gathering data on all the elements in a population, we'll just say, hey, let's just get a sample of the population, right? So from the population, we'll select 300 people and we'll survey them. And how do we go about selecting those 300 people? So that's what like sampling is about. Like what do we do? Like how do we choose them? Should I just choose the 300 people closest to me? Like what's going to be a representative sample? What's going to be representative of the population? So we want to get a sample which best represents the population. And that's like an interesting thing in statistics because you could create studies, experiments. You could do sampling where you you know, influence the outcomes based upon how you structure your experiment or your sampling. And so, you know, you could do like statistical analysis and experiments and studies where you get the outcome you're looking for as opposed to the outcome which is truly reflective of the world or the population, right? But the sample is a subset of the population. So instead of surveying everybody in every citizen in America, each element in America, every citizen, right? We could say we just want to do 300 people. So that will be a subset of the population. And so what we do is we create a frame, and a frame is a list of all the elements that the sample will be selected from. So we might say, hey, the frame is going to be, we're choosing, you know, 100 people from every state. And then we'd find some way to choose 100 people from every state. And so that would be like, and you know, and so maybe, you know, we would have 500 people from every state, and then we choose the 100, or we'd have like all the people in every state, and we choose 100 from each state randomly. That would be our sampling technique, is just to randomly choose the people. You know, we'd have a list of every person in each state, and from each state, we'd randomly choose 100 people from each state. So we'd end up with like 5,000, 50 states, right? 5,000, 50 times 100, 5,000 elements in our sample. And then the goal of that is, you know, inferential statistics. Inferential statistics. And inferential statistics is we you know, study a sample to make inferences about a population. Okay, so I'm just going to make this a little bit smaller. I'll make both these a little bit smaller. Boom, and we'll make these, I don't know, 18, and we'll also make these like 18, just de-emphasize them a little bit. There we go. So here we have population, sample, element, and then we have a couple of other things. And so the stuff in bright yellow is like new stuff or the most important stuff, population and a sample. So instead of studying the entire population, you study a sample. And what is the, you know, what are the different techniques for doing the sampling, choosing who's going to be in the sample. And the frame is the list of all the elements that the sample will be selected from. So you create a frame, some sort of like, just framework. You create some framework for how you're going to select the, do your sampling and select the elements from the population that will be that will be potentially available to be in the sample. And then when you do your study on your sample, that allows you then to make inferences. The sample allows you to make inferences about the population. And we're going to see that, those inferences, we're going to see how we could get a certain amount of confidence that the inferences that we're making, there's a certain amount of likelihood that, we're accurate to a certain degree or within a certain degree. Because if you think about it, if you do a sample, shifting gears here. So we were talking about terminology. Now we're shifting gears a little bit. And so that's known as, let me just go back to this. That's known as inferential statistics, where you have a sample and you make inferences about the population. All right, so that's inferential statistics. We've also been looking at, descriptive statistics. And descriptive statistics, we had visually descriptive statistics, which were like the histogram and the dot plot and the, bar chart, which I always think of as a column chart. And then we also had numeric descriptive statistics, which is mean, median, mode, variance, standard deviation, range, interquartile range, your quartiles, your coefficient of variation. These are numeric descriptive statistics. That's descriptive statistics, right, that we just talked about. So this is inferential statistics. And so it's just like if you do an ontological structure where it's like a tree diagram and you're saying, hey, here's this idea of statistics, and I don't know, maybe I could create it here. Insert a diagram. That's pretty much the one I want, and I want a hierarchy diagram, and I'll just go with like this one here. And can I select this whole thing? I'm gonna like Control Z on that, and then just put in this here and do a blank like that, and then I'll put in that one. No, I don't like it. I'll put in this one. And so this would be like this would be statistics. And so, one of the areas of statistics is descriptive stats, right? And then one of the areas is inferential stats. And in inferential stats, we have samples. And so I'm just going to delete these and just leave it like that. So bye-bye to those. So that's an ontological structure. I love the word ontology. I don't know if I've introduced you to it. I probably have, because I just think it's great. And anybody who goes to school, has me for a teacher, they pretty much leave understanding what ontology is. So not only is it the branch of metaphysics dealing with the nature of being, which is awesome, and you should look up metaphysics. And just to save you the time, here's what metaphysics is, the branch of philosophy that deals with first principles of things, including abstract concepts such as being, like, how am I here? Knowing, how do I know stuff? Substance, what is stuff? Cause, like, hey, is everything operating on cause and effect or karma, or how do things work here? Identity, who am I? Great spiritual question. Time, what is time? Is there time? Is time only intellectual concept and intellectual abstract that the human mind has put on top of reality, and actually reality is timeless or eternal? And space. And one of my favorite philosophical conundrums is like, the way we understand the world is for something to exist, it has to begin. But so for the universe to exist, taking that philosophical construct, for something to exist, it has to begin. Well, for the universe to exist, it has to begin. But if it began, what did it begin into? Right? Like, can something begin and into nothing? And if it didn't begin into anything, then what is that? What is not having space? What is that nothing? So, if the universe began, what did it begin into? And if it didn't begin, has it just existed forever? And how does something exist forever? We can't understand that. So ontology is the branch of metaphysics dealing with the nature of being, but it's also a set of concepts and categories, in a subject area or domain of knowledge, statistics, and it shows their properties and the relations between them, right? Here's descriptive, here's inferential, and the relations between them. They're both a subset of this larger idea of statistics. So it's an ontological structure. I love it. One of my favorite words. So that's the definitions here, and that's inferential statistics, and that's an ontological structure. It seems like there's something else I wanted to say about that. I guess that's it. And the next slide here in the introduction is the reason we select a sample is to collect data to answer a research question about a population, right? So we're choosing a sample to understand a population. The sample results provide estimates. I remember what I wanted to say, right? So the sample results provide estimates of the values of the population. Estimates of the values, I'll put this here, and we'll, I guess, make it a different color for fun, of the estimates of the values of the population. And this is interesting, they call it characteristics. The reason is simply that the sample contains only a portion of the population, right? Sample is just a portion of the population. With proper sampling methods, so what's our technique, our framework for sampling, the sample results can provide good estimates of the population. So I don't know why they put good in quotes there. So good means you have a certain amount of confidence or within a certain known degrees. And so the reason this is interesting is because if we have, like, I don't know, how many people are in America? Population USA. If we have, oh, that's super interesting, 3.333, whatever, 333.3 million. So if we have that many people in America and we do some sampling, one time we might get a mean, like let's say we're just sampling height and how tall are people. One time we might get a mean where the mean is 5 feet 6 inches, and that's out of 1,000 people, or let's say that's out of 20 people sampled. Another time, that's not very many, 20. Another time we might get a mean where people are 5 foot 8 inches. Another time we might get one where people are 6 foot 1, right? And so our samples can have different data, and so because the sample is only a portion of the population, and the more people we sample, the closer we get to the true characteristics of the population. And so the more people we sample, the closer we get. And so we're going to look at, like, in this idea that I could do one sample, or let's say I could do 10 samples and see what are the different means. Like, let me sample 50 people 10 times and then compare their means. And we'll see that those means could be different for each sample that we did. And then we could calculate statistics on all those samples, right? So, we have our samples, we do 10 of them. Well, these are each like random variables. And in each of these random variables, we could look at all this data as a collection of data, right? And then we could calculate data on the data, or we could calculate the mean of each of the samples. So this sample, maybe everybody's 5 foot 6, so they were 5 foot 8, here they were 6'1". We would get all the heights of the means for each of the samples, and then we could find the mean of all those means, right? We could find the average of all those averages. And so you start doing statistics on statistics, which is part of what we see in this chapter. And we start to see a distribution. If we had 10 samples, we start to see how is that mean distributed. And if we do enough of those samples, then we see that some sampling distribution, right? Some sampling distribution starts to emerge where there's some sort of a skewness or symmetry. Is it skewed left, skewed right? Is it symmetrical? Is it normal distribution? And so that's what you start to see, and that's what you start to think about when you're working with a sample, is this idea that, if we did 10 and we had different means for each one of those 10, we could then find the mean of all of those means. And we could think about that, and we could look at how is all the data for each of those samples, what's the distribution of all that sample data. And so we're doing statistics on our statistics, which is interesting. All right, so in the next video, we're going to take a look at ideas on selecting a sample. How do you go about doing that? And that's an introduction to sampling and sampling distributions.